Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic function graphs, specifically how we can find the axis of symmetry for these graphs, and we'll do it in 5 minutes or less. So we have an example of a basic parabola here, and we see it's downward facing, and this is actually the equation in standard form for this graph. Now, when we are asked what is the axis of symmetry, what we're thinking of is we are thinking of what is the imaginary line that you can put that is vertical, that you could fold this parabola in half and you would get identical sides. We see it's pretty clear right here. Visually we can see we've got a vertex right there. Seems like that's going to be at 1, 1. But really what we're looking at is what is the x value of this axis of symmetry that is going to cut this parabola exactly in half, right? And we would say the axis of symmetry, we would say x equals 1. Because no matter the y value, as long as your x equals 1, you're going to have the axis of symmetry. So that's what we would say for this if we were just looking at the graph. Sometimes we might not be given a graph, so that's why we also have a formula we can use. X equals negative b over 2a. Now that might not make much sense unless we think standard form. So remember, when we're given standard form here, we've got 3 different numbers that are going to be typically given to us, right? A and b are going to be coefficients for x squared and x, and then c is just a constant, right? So let's take a look at the actual function here, right? So in this case, a equals, we already said right there, negative 3, and b equals 6. We need those two. We don't necessarily need the c. That doesn't help us right here. So let's plug that in. We can say x equals negative, okay, and then what is my b? 6 over 2a. 2, and then a is negative 3, okay? So that's going to be x equals negative 6 over negative 6. The two negatives are going to cancel, so it's just going to be 6 over 6 equals 1. So we could have figured this out by just visually looking at it. We also could have figured it out by using this equation right here, as long as we know in standard form what is the a and the b. Let's look at another example. So we have another graph. This one is facing up, and it looks like my axis of symmetry. So there's my vertex right there. It's going to be right there. And I'm thinking that's going to be x equals negative 1.5. I know it's between negative 1 and negative 2 there. And I'm just going to write this down as around negative 1.5, but since we actually do have the equation, that's when I definitely want to double check, because I know it's not an integer, and so maybe it's, negative 1.45 or something weird like that. So how do we double check it? Well, once again, let's go to our standard form. Let's identify our a and our b. We don't necessarily need our c. So what is our a? Well, our a is going to be the coefficient right in front of that x squared. There's nothing there, so we can always assume it's going to be 1. So what is our b? Our b is going to be 3 because it's in front of the x. That's really all I need. I don't need that negative 5. So let's go into this equation right here. X equals negative b over 2a, and I'm going to substitute the b for 3, and then the 2 stays there, and the a is going to be 1. So really it's just going to be negative 3 over 2, which is 3 halves, which is 1 1/2, which is, we were correct, negative 1.5. So when you're looking for the axis of symmetry, sometimes you can just eyeball it. It's very clear it's going to be an integer. But if you ever get the standard form of the equation, that's going to be very helpful. You identify the a, you identify the b, you plug it into this little equation right here, and you can find it with x equals negative b over 2a.